Our next speaker will be Petr Špaček, that will tell us about parent versus child-centric resolver interoperability testing.
Hello and thank you for listening to the experience we've gained while changing bind to be parent-centric. Can we get a timer reset? I'm nervous that I'm over time. In this talk, we will very briefly go through the mandatory recap, what's this parent-child schema in DNS, then spend most of the time on the interoperability testing results, and very briefly look at the embarrassing part of the performance. If you're in this room, you already know that DNS is a wonderful system where nothing works properly. You know that on the parent side and child side, NS records can be inconsistent, and they are. There was a wonderful research by our session chair, and there's a website where you can read more details, look at the slides. I will summarize it with one number, 8%. By the end of the study, at the end of 2019, 8% of delegations had inconsistent parent and child NS records. So, well, that's about the quality of the data we have to work with. If DNS was a drink, it wouldn't be very good one. That's a new one. I thought that a P in the PDF stands for portable, but apparently not. And now I cannot move the slides. Can someone click the OK button, please? Thank you. Another source of inconsistency might be the glue records. That's the same story. It breaks in interesting ways. With that recap out of the way, let's have a look why even consider going to parent-centric model in the resolver. First is kind of philosophical point of view. Well, to get to the child, you have to go through the parent at least once. So the parent has to work, and if it doesn't work, you never see the child, so then why don't stick to parent side? Second, more practical point of view is that our support organization very often encounters the enterprise deployments, which very much like load balancers. And the parent delegation might be like 3 or any number of load balancers, and then any individual load balancer responds only with itself if you ask for the Apex NS record, presumably with TTL 0 because it's load balancer, they have their own reasons. Sometimes the name doesn't even exist, the name on the Apex, so it breaks in like very interesting ways. This can be generalized at what is the resolver supposed to do when it tries to get the child side record and then something happens. For years and years in a row, Google domains were giving refused if you asked for Apex NS record. And everything worked. No one cared. Because the resolvers have code to fall back from child side to parent side when the child doesn't work. And then, okay, so why we even bother with the child side? And there is a number of reasons which can go wrong, and basically all of them happen in practice, so yeah. Last nail in a coffin for bind was a security issue we had last year, where researchers found a way how to misuse the shared glue to mount a cache poisoning attack. The traditional bind had one global cache per view, and the individual delegations and glue records went into the one pile, basically into one shared glue, cache. And here on the example, can I point? No, I can't point. Never mind. Here on the example, we have two delegations. One is for sub, second is for test, and they both have the same name server name. Obviously, it's within the same parent, so both delegations will be sent together with a glue. For the test delegation, that's called sibling glue because the glue is not within the test, but it's like sibling under the same parent. And that's the mechanism the researchers were able to misuse to mount cache poisoning with in an innovative way. And now the trouble was, okay, so how do we fix this? Because it's in the DNS protocol, and we don't want to re-architect the architecture in a CVE fix. We like to have the fixes for security issues minimal. And so we ended up with the idea of rejecting sibling glue. which according to RFC is fine, because the resolver is able to make the separate query for that glue name and get it separately, and it should work. That's what the RFC says. With the exception of the cyclic sibling glue, which reportedly back then affected 1 delegation out of 1,000,000. So it was like, yeah, maybe good enough for CVE fix. That was the theory. In practice, 1 out of the 1,000,000 was a Congo TLD, which actually did depend on that cyclic sibling glue. Of course, not like immediately visible, but it was like deep in the DNS tree. And of course, it had inconsistent parent and site NS records. So we just broke the Congo. Sorry about that, it wasn't intentional. This is just the illustration of how the cyclic sibling glue works. Right? Of course, it was more complicated, it was more levels of indirection in reality. But here the bar delegation is using name within the foo domain, and the foo domain is using name server name in the bar, and you get the idea. So, well, so much for trusting what the RFC says. Unfortunately, our testing didn't catch that, because we did have Congo domain in the test data set, but only 1 out of 100,000 queries. And of course, there is some noise in the test, so it was like, yeah, well, well, we've learned to test better now. Last but not least, the DELEG protocol as currently proposed is always parent-centric. So from engineering perspective, it kind of makes sense to use the same approach and have 1 resolution algorithm instead of 2 independent. So it's kind of nice architecturally. So we decided to go to parent-centric, which would, besides other things, would allow us to fix the sibling glue or accept the sibling glue again in a secure way. So just for comparison, the traditional bind was, I perhaps incorrectly say child-centric, but we just followed the RFC 2181, which basically says, if you see the child record, you just replace the parent record with it, and from that point on, you use the child version of it. So that's what the bind was using. It didn't proactively query for the child side NS records, but when it happened to have the child side in the cache, it preferred the child over the parent. That's what it was doing historically. The new version, starting with 9.21.21, and I have to say with many, many bug fixes on top of that, so just don't stick to that number, use the latest, please. Introduced different cache, which is used only for referrals. So the parent side NS records and a glue are stored in one place, and the child side NS records and everything else basically is stored in another place. These don't mix together, they don't overwrite, we keep both copies. If a client explicitly asks for NS record, it will get a child version with RR6, so it can be validated and so on and so on. But to actually do the recursive resolution, we will use the data from the referral cache. So only the parent version of the zone cut and the glue. And here the glue is now tied to that specific name it was sent with. So even if the attacker manages to spoof glue for one particular delegation, it will not affect the other delegations using the same name. Perhaps worth mentioning is that the query name minimization is still on, but if it happens that the query name minimization accidentally discovers child side NS record, it will just stick it into the DNS cache and not the referral cache, so it will not be used for actually following the delegations. Now, the question is, how do we make sure it actually works, and preferably without breaking Congo again? To do that, we are using a toolchain called Resptive, developed by CZNIC. In a sense, it sends the same query to different instances of a resolver in parallel. Then the resolver does its thing. It goes to the internet, does the resolution process, answers back, and then we compare the answers. Easy as that, except it's the live internet, so it's super noisy. It's like, you know, taking a microscope and looking at your hand. Are there any microbes, any bugs on my hand? Well, there is a billion of them, but the question is there any which will kill me? And that's the actual question we care about in interoperability testing. because, you know, there are differences because it's the internet, but is it actually breaking anything if we answer differently? We'll see. This is a complicated topic, which was discussed a couple of hours back. You can have a look at the slides and video. It is available for here. Let's fast forward to what we did and the results. Our test set had roughly 99,000 unique queries. We've repeated the whole circles 277 times, and each repetition consisted of 3 different tests. One was child-side or child-centric bind running in parallel to another instance of child-centric bind, and that was, in theory, it should produce the same answers, but of course it doesn't because it's the internet. But we wanted to find out what's the noise level. Then we've repeated the same idea, the parent-centric and parent-centric in parallel, again, just to see what the noise would be, how it changes, and then the actual real stuff we care about, the child-centric and parent-centric in parallel and comparing the answers between these two. Here we have the visual representation of the results. On the vertical axis, that's a number of DNS responses with differences detected in the given field. On the horizontal axis, we have a number of test runs out of 277, which had that particular number of differing messages. I mean, it's basically a histogram. It's just many histograms at once. So the way to read that chart is that for half of the tests, 160 messages or more were different. That's the line, that's the median value. So 160 messages or more were differing in any single test run. So now, what does it mean? Of course, we don't know, because so we had to inspect manually, and long story short, after significant time spent on it, AD bit, TC bit, or generally flags, answer types, and RR6 present in the answer messages are, to use the term of art, the stupid DNS tricks. The CDNs are just changing things. So if you ask 2 things in parallel, you get different answers, but that's okay. We found out that that's the intended behavior of the CDN, so yeah, whatever. So we are basically left with R codes, which is luckily much smaller set, much easier to inspect by hand. We've repeated the same test, now running the parent and parent-centric version twice in parallel again to find out what's the noise floor. You can see that it's a little bit lower, a little bit less noisy than the child-centric resolver, which is nice. And then the real test, comparing the child-centric versus parent-centric, running in parallel, and now the number of differences in R code jumped up. So it's like, okay, this doesn't look good. But again, we had to dive deeper and analyze it like one by one. But when we categorized the differences, we found out that actually it's a good sign. Because here, next to the bullet point, is the R code produced by the child-centric resolver, and next to the arrow is the new R code produced by the parent-centric. And you can see that in many cases, it flipped from serve fail on the child-centric to no error or NX domain on the parent-centric. In some cases, it went the other way and broke, so it went from no error to serve fail. And in some cases, it flipped between NX domain and no error. But I mean, it was no error but no data anyway, so who cares? So there are differences, but they are actually the nice kind of differences where we are able to resolve more than we were before, which was kind of surprising. While inspecting this one by one, we found 100% reproducible permanent failure on the parent-centric resolver. And the weird thing is that this was specific to query type HTTPS specifically, but A and Quad A does work. And how is that possible? Because the delegation is not type dependent, or is not supposed to be. So what is going on here? When we look at the specific name server sets for that specific zone which contains the query name, we say that the parent has 3 name servers. The same 3 are present for the child, but the child has 4 extras, which are, the child is superset of the parent. And then when we queried the parent, the 3 servers present in the parent, they time out. When you query it, specifically query type HTTPS, because why not? Probably it's security measure or whatever. The 4 extras, which are present only in the child, actually do answer for HTTPS query type, but parent-centric will never see the child-side version, right? So that's why it times out. So now for a while, we were in a bad mood. It's like, okay, so what do? We just broke something, and can we release this? And well, it turns out that the Google public DNS, which is also parent-centric, is not able to resolve it either, 100% failure rate. So it turns out that it was broken since the HTTPS was invented for at least 1/4 of internet population. So it's like, yeah, okay, this is so misconfigured that we probably can just close eyes and move on. So with that failure out of our way, we can look at the performance measurements. And I have to say that this is really embarrassing for me to stand here because it's buggy, we know about it, but we don't have time to fix it. The reason why will be explained in lightning talks today. Here is latency histogram. We are DNS folks, so we are bound to be obsessed by latency. Again, the vertical axis is the latency in milliseconds, horizontal axis is a percentile, but I will just, long story short, the closer the line is to the lower left corner, the better the performance is. That's what you need to know. Here you can see that the blue line, which is data from the child-centric resolver, is closer to the lower left. That means that it's more performant in terms of latency. At the same time, this doesn't make any sense at all, because the metrics from the resolver say that the parent-centric resolver sends 6% less queries to authoritatives, and the parent-centric experiences 19% less timeouts out while doing so. So how the heck it can be slower, I don't know. Again, we know that this is probably a bug in the code base. We will be digging into that when we have time, which is not now or not in next months. Memory usage is easier story to tell. It's a little bit higher, which is expected, because as I said, now we store the glue separately and for each delegation, so the cross-domain cache poisoning cannot happen. So that is expected to increase the memory usage a little bit, but it is almost within measurement error, so I mean the difference is so small that it basically is not important. For CPU usage, it's the same story but in reverse. You can see that the red line for the parent-centric resolver is like copying basically the blue line just a little bit lower, but again, it's like basically within measurement error, so it's maybe a little bit faster, but who cares? The difference is not important here. So, to sum it up, from interoperability perspective, it seems that being parent-centric and using only the parent side of the the zone cut is actually better, because in our tests, we are able to resolve more domains, see less serve fails than while using the child version of the NS record, with the exception of the one broken, magical domain, which doesn't answer HTTPS. And the performance, I would prefer not to talk about it before we fix it. Thank you for your attention and time.
Thanks, Petr. Question from the associate cabinet.
I'll first.
Hi, thank you for the work and the presentation. I mentioned this, I think you guys submitted a RFC, or an internet draft about this idea, is that correct?
Yes, that's correct, and the draft was done after we've done the implementation.
We won't talk about that. But I remember asking during that, so this cache that you've created, now the resolver has information about name servers, but if you query the NS records, that's not what it's going to return.
Yes,
so you now have state that there's no way for an external user to see about what the browser is doing. Are you planning on introducing something like private EDNS option or something like that to allow me to peek into that cache. And while you have that, you might as well open the address cache and things like that.
Yeah, I mean, there are possibilities. So far, we didn't have really time to do anything with it. I mean, the easiest thing would be just stuff the parent side DNS records into the additional section, and you can see it. I'm not saying it's a good idea. I just said it is technically possible. But yeah, I can see long lines, so perhaps we can discuss over lunch.
All right.
Right?
Yeah.
Whoever.
Yeah, hi, Petr. Yeah, Ray Bellis, also IC, but not in the bind team. For us older guys with long memories, you might want to go look at the presentation Olafur Gudmundsson did 15 years ago at an OARC San Francisco workshop. He did analysis of basically of how you actually identify whether a resolver is parent-centric or child-centric, or the other term at the time was child-sticky, where once it had gone to a child, it would never, ever go back to the parent again. So there was a lot of good stuff done back then by that time, and certainly worth looking. And I've put the link to the presentation in the workshop channel.
Okay, thanks.
Yep. Giovanni Modus, IDN and TU Delft. Thanks for opening this can of worms, really. I wonder, like, clarifying question, which kind of domains you chose to evaluate doing those tests? How many domains there were, like when you run all those tests in the zone?
Seriously.
So like you had a set of domains, right, to evaluate the resolution, to compare the results of parent to child-centric.
Are you asking about the interoperability test or the performance? Because these are different sets.
Interoperability test.
Interoperability test. That's 100,000 query, most frequent queries we see in the telco data set we have.
All right. And
unique queries.
Is this published as a paper or somewhere else?
I think that if you look closely in our GitLab, you will find a file somewhere. Like I can send you a link.
Thanks. Thanks. Great work. Yeah.
Hi, Tomasz PCH. Thanks, great talk and everything. I'm always get surprised by resolver algorithms, and I'm always learning something. So
my question is,
my question is, I never like the fact that there are like NS records at the parent and the child as well. But anyway, the child is where the NS record is being signed. It's not signed at the parent. And I do not see yet if this is like any concern or anything like during the resolving of the names.
Well, you are right, with the exception that the child side doesn't work so often that the resolver basically has to fall back to the parent when the child doesn't work. And that means that the attacker just makes it not work. And then it will fall back to parent, which is not signed for mysterious reasons. And end of story. I mean, the signature is there, but it's useless, basically.
Okay. Oh, okay.
Because of these reasons on the slide. I mean, all of these happen in practice, and we have to have workarounds, otherwise the resolution wouldn't actually work in the child-centric resolver.
Thanks.
Hi, Bill Woodcock, also PCH. My question is related to Shane's. I'm hoping that in the shipping version you have or will have the ability to log a non-fatal error when there is a mismatch between identical records in the two caches?
Well, in normal operation, you never see the child side record at all, so you have nothing to compare against.
Well, right, but when you do have the same entry in both and they don't match, that would be a good indicator that there's a problem, right? Are you saying that?
Well,
for some reason that would never happen.
8% of domains has it for a decade. So I don't think that anyone actually cares, because if people, I mean, zone master, DNS-Wiz, everything will flag it, and still we have 8% inconsistent. Okay. So I don't think that it belongs to a resolver, which is performance critical. Zone master can do it anytime offline, asynchronously.
Ralph Weber, Akamai, thanks a lot for this. I'm liking it a lot. And I wanted just two remarks. So first of all, the HTTPS does not work. I mean, anytime we introduce a new queue type, stuff just fails. And I mean, everybody has increased surface, so it doesn't surprise me at all that one of the things fails. It's good that it fails for everybody. And the other thing I want to note, while I work at Akamai now, before I worked for a company called Nominum, and we did the test of parent versus child, something like over 20 years ago, and came to the same results. And I'm really happy that it's the same still. Thanks.
Yeah, it's still broken 20 years later, yes. Thank you.
Hi,
I actually have a comment that is, we went after the root, the domain in the root zone and all the TLDs, and we tried to fix basically their parent-child inconsistency. And when we wrote paper, we actually solved the problem of the roots, but apparently they broke it again. So things keep broken.
Yeah, I mean, it's operations, right? This is not a bug which you can fix once, but this is operations, and you have to keep it consistent all the time, which is probably another argument why not to ever look at the child side, because then if the parent breaks, you know immediately, because it breaks for everyone all the time. Yeah.
Thanks, Petr.
Thank you.